Carbon-14 is a radioactive element present in living organisms. After an organism dies, the amount A of carbon-14 present begins to decline at a rate proportional to the amount present at the time of death. The half-life of carbon-14 is 5,730 years. A piece of fossilized charcoal is found that contains 15% of the carbon-14 that was present when the tree died. How long ago did the tree die? So we use A to represent the amount of carbon-14, and we use T to represent the time in years in this case. So the given condition tells us the amount A of carbon-14, so the amount A begin to decline at a rate. So the rate dA over dt. Whether it's decline or increase, we still use the constant K because we're talking about proportionality, okay, proportional. And if it's declining, K is a negative number, which we will be able to solve for at the end, and we will notice it's negative. So it's proportional to the amount at the time of death. So this is the moduling differential equation. So the rate is proportional to the amount at the time of death. Now half-life of carbon-14, so how do we understand that? So A of the time, right? A at the time 5,730 years, it's only give you half, only a half remain, okay? So whatever amount is presented in the beginning, A of 0. So we assume the amount at time 0 is A0. Or we can make it even simpler for us, right? Because it never say how many is left, and we are only talking about half, right? And then 15%. So we can think of it as the amount present in the beginning. So at time 0, it have 100% of the amount. So at A0, we have 1. After 5,730 years, we only have half of it left, 50%, right? So it's 1/2. So then the question is, how long ago? Okay, we don't know the time. Did the tree die? Okay, but right now we only have 15% of it. So which is 0.15. So what is the time right now? This is the question translated into mathematical equations. First, we solve this separable differential equation. So we divide A on both sides, right? And we multiply dt on both sides. So we have 1 over A dA equals K dt. We integrate both sides, just as we did in example 2. So we get log ln of A, absolute value, but it's always positive because we're talking about the amount, so we don't need the absolute value, equals K T plus C. And then take the exponent on both sides. A will equals e to the K T times another constant. Okay, so because A of 0 is 1, so 1 equals A of 0, right? E to the 0 power. What it is telling us A of 0 is 1. So the moduling formula or moduling function A of t is 100% of the amount, right, times e to the kt. So we need to solve for k by using the second condition. Only half of the amount is left after 5,730 years, okay, times k. So then we can solve for k. How to solve for k? We'll use our algebra. Take natural log on both sides. We get ln of 1/2 equals 5,730 k. Now what's ln of 1/2? It's the same as negative ln of 2 because it's 2 to the negative 1 power. So we get k is negative ln of 2. We divide both sides by 5,730. So that is k. So now we rewrite the governing function. A at the time is 100% of the amount e to the negative ln of 2 divided by 5730 t. Now how long ago did the tree die, right? What is t that give you 0.15? This is what we need to solve for. Solving for t. So again, we take the natural log on both sides, so ln of 0.15 equal negative ln of 2 divided by 5,730 times t. So now t, we divide both sides by this number. So t will equal negative ln of 0.15 divided by ln of 2 times 5730. So you can use a calculator to find out this number. It should be a positive number. But if the question didn't tell you the wrong, just enter this number exactly as an exact number.